Okay. It's Friday, and we're going to do this tonight. Yes, well, we're going to do our best shot at it anyway. Tonight, if you're here, this will probably be clipped from the VOD, but yes, tonight we're going to be working on doing a one-shot of making a circuit board from scratch using a 3D printer. It's going to be a tall order, but we're going to try and do a one and done. Just mainly to see whether, one, do I have all my variables under control now? And two, to see whether, or should I say, see how long this process actually takes versus going out to a board manufacturing. So we'll give a few minutes to get everybody that's going to join us from the very, very beginning. And if you're already here, welcome, welcome, welcome. You are in the hot seat. You get to see a little bit behind the scenes. And yeah, this, like I say, this will be clipped from the VOD. So consider yourselves part of the elite crew. Road Rally Race, welcome, welcome. Why don't you just get made in China? Well, I'm going to cover that. I am going to cover that. Right, okay, we may as well just get into it. So, welcome. We are 3 streams in. This is the 3rd stream attempting to make circuit boards at home. And there's a really good question in chat right now is, you know, why don't we just get these things made in China? There's a couple of reasons. And of course, if you're living in the US, the whole sort of situation at the moment on tariffs and getting things in and out, you know, it's kind of up in the air where things are going to go. It's a bit uncertain. That's not the primary reason, though, but it is a valid reason. The reason that I'm going to be making them from home is that I need a quick prototype, single board. The vast majority of board manufacturers will want you to have a minimum order of 5 boards. Don't have a requirement for 5 boards. I only need 1. And for getting a quick prototype out or a quick board to help you do some work that is not, it's an intermediate step. It's not the final step. Making your own boards at home, whether that be on a CNC machine or using the techniques we're going to attempt tonight, is a really good option just to keep your process moving forward. You're looking at least a minimum of a week turnaround time, which the reality is, you know, that's pretty quick. And the quality of the boards that you get coming back from these manufacturers, they're pretty clean, right? They're what you would expect from professionally made circuit boards. And I've got examples of where I've used these sorts of services in the past. For example, using this little ESP8266 board. You know, it's a double-sided board. It's incredibly clean. You know, I'm really pleased with how this particular board turned out. And yeah, I had time to wait for this. But the reality is, for the project that I'm working on, I need a quick board turnaround. And yeah, okay, I probably could have ordered it from China and had it here by now. Given the experimentation and investigation that I've done going into this, but I guess that's the point, right? This is a learning experience so that I can take this not necessarily into this project, but the next project I can leverage that knowledge and skill. So, seems we're doing a one and done, but no, Rally Race, thank you for that question. I know it was potentially a rhetorical one, hence the smiley, you know. But it's still a valid question. So we're going to go from beginning to end. We will skip through things a little bit quickly, but I will cover all of the points from ground zero all the way through to a finished circuit board. Ideally, something that is usable, but we'll see. We'll see. So we are going to be using a 3D printer to make a circuit board. Specifically, we're going to be using a resin-based printer, and that is an incredibly close shot of my printer. Let's just see if I can't zoom that out a little bit. That's as far out as that will allow me to go, but let's open up. This is an Anycubic Photon S 3D printer, and we're going to be using this to make the circuit boards. Make a circuit boards with a 3D printer, you say? How is that possible? Well, the theory is this. We're going to coat a copper-clad board with some photosensitive material, and then we're going to use the 3D printer to expose the circuit design onto that so that we can develop it and etch it and hopefully have a working circuit at the end of it. Now, to this point, I haven't been successful. There's been a lot of trial and error. And whew, boy, has there been some trial and error. This was the closest I got on the last attempt, and that was an etchant, and it exposed really well, and I messed up. I forgot to flip my artwork. What a clown, right? So I made a mistake. So I redid the whole process. And I came up with this. Now, there's a few problems with this. One, it was with the application of the UV cure coating. And secondly, I don't know if you can make that out, but all of the pads here, they're actually shorted out. So I don't know whether or not that was overexposure and there's been bleed between the pads and the ground, or whether or not I just didn't leave it in long enough to etch, and I was a little bit hesitant. So I'm reasonably confident that we're going into this with a reasonable chance of success. So will I be trying an FDM printing method for a PCB one day? Well, it all depends on what we're talking about. If we're talking about printing the circuit onto the copper-clad board and then etching it, or whether or not we're looking at printing with a conductive material, that's an interesting concept. That is an interesting concept. The challenge that you have using FDM, though, would be the nozzle size, and that would be the limiting factor on how thin your traces could be, regardless of whether you're printing a mask to etch or whether that is something that you're doing to print conductive material. So I don't think FDM printing's quite there for this just yet. I mean, we could try it, but I think it has a high chance of failure. Right, okay. So without further ado, let's get into this. I've done a bit of prep work. So here is my folder structure. Let's go into my KiCAD project. So I use an application called KiCAD. It is a CAD application specifically for designing circuits and circuit boards. It is open source. It is available for Mac, Windows, and Linux. And it is an incredibly useful and powerful open source application for the purposes of making circuit boards. So the first part of the process, if you're new, if you've seen the previous live streams, this will be covering some ground that we already covered in those live streams. But for anybody new here, what oh, sorry, we have to highlight this comment, right? I like projects with high percentage of failure. I like getting involved in. I like getting involved in things that I have no business getting into because that's the maximum learning curve, right? So I want to learn the most I can in the least amount of time. So anyway, so to recap, we're going to be covering some ground that we already have in previous live streams. So if you've seen those, I'll skip through this as quickly as I can. But for anybody new or watching the VOD for the first time and you haven't seen the other live streams, we're going to cover off the basics of what it is we're attempting to do. So we need to build an interface circuit board. We're testing out a piece of equipment that has a flat cable, and we want to break that out so that we can connect it to some test probes, some control devices, and so on and so forth. And we're trying to experiment with a piece of equipment we don't know how it works. So we want this board to help us interface with it, figure out how it works, and then once we know that, we can design a circuit board that will do the job in its entirety. So this is an intermediate step. So the first thing you've got to do is to create a schematic, and a schematic is essentially just a map of your components that you're going to use and how they connect together. This is not going to be a schematic design tutorial, but I'm just going to skip over the concepts, and then we're going to get into the actual detail of what we're going to try tonight and hopefully get a successful result. So we have two connectors. This connector on the left-hand side is the flat connector, and on the right-hand side is a series of screw terminals that we can then connect some wires to, connect some probes to, and be able to interface with this device. So once we've got a schematic all drawn up, we have to assign what are called footprints to the components. The more components you have on your board, the more footprints you have to assign. And yes, you have to assign them one for one, right? So you do that by using the Assign Footprints tool, and that brings up a window. Now you have to create a library from scratch, which is totally doable, and there are plenty of tutorials on YouTube how to create your own footprint and symbol libraries for KiCAD. And essentially you get this footprint assignment window where you get a list of components, and over here you get a list of all the different types of components that you can select. And you use the search option to drill down into this vast library, and then you assign each one. And we can kind of go into these and, let's say, for example, right-click and view the footprint, and that gives us what that's going to look like on the circuit board when we design it. So once we've assigned all our footprints, we can do some design rules check. And again, I'm not going to go into that in great detail. We go into our board layout tool, and the board layout tool, this is where we define what the circuit board is going to physically look like. So we have our footprints that come into the library. We get footprints that come into this package, and then we have to define the edge cuts, which is essentially the perimeter of the board. So you can have either a rectangle, you can have circles, you can have a custom shape if you so wish. So you can bring in, I think it's DXF and SVG files into KiCAD and import your board outline to lay out all of your components on. Once you've placed your components, you then have to draw the traces between each of the components. And if I just delete one of these wires here, one of these traces, you'll see that there is a line from here to the actual component, and these are called air wires, and these air wires are a visual representation of where your traces need to go. And in fact, it's a guide for you to be able to manually trace it. You can use auto routers. There is an auto router for KiCAD, and that takes some of the heavy lifting out of it. but these aren't always optimal. So a lot of experienced people who make PCBs on a regular basis very often like to use a auto router for the bulk of it, and then they may actually switch over to hand wiring them. So once we've got that, we can look at our circuit board, we can hit the 3D viewer, and we get to see what the board is going to look like when we make it. Now, this component looks a bit weird because I actually modified something which is in the library. It was very close. It was a surface mount component, but I actually need a through hole. So I modified the footprint in my custom library, and then I was able to make do, shall we say, with what we've got. So there's a lot of critics in chat talking about the symmetry or lack of symmetry on my circuit board. It's actually laid out like this for a reason, if I'm brutally honest. So the cable is a flat cable, and where did I put it? I put it here somewhere. Ah, here we are. So it's a very short flat cable that we're using to interface with the device in question, and that happens to be on the one side of the board. So that's justified to the left of the board, and the screw terminals are justified centered on the board. So yeah, I mean, you know, how did the board turn out, your lass? So this was my first attempt, and I got a good exposure. So I now know the exposure times. But the problem I had was I didn't reverse my artwork. So the artwork backwards on the copper plate, and the copper plate was starting to wear thin. So I did another go, and you got this. That's not half bad. I mean, there's good isolation on the traces, but there's a couple of problems with it. So we've got an application problem here, and we've got an etch problem here. I don't know if it is a slight overexposure, but these pads are all shorted out. So we're going to be hopefully doing a one and done tonight from beginning to end. So back to what we were just talking about, and that is, with our circuit board, we now need to export the Gerber files. So Gerber files are manufacturing files. If you wanted to have this board manufactured professionally, you would export these Gerber files, you would zip them up, and you would upload them into the manufacturer's website, and they would then give you a quote on how much that board's going to cost, right? So these are pretty industry standard files. So we export the Gerber files, and then we're going to do that now. So we go to File, Fabrication, Outputs, and we go Gerbers. And for my purposes, all I need is the bottom copper. I need the silk screen, I need the mask, and I need the edge cuts. So we're going to go ahead and hit the plot button. And like I say, I'm skipping over this at an incredibly fast pace and at a very high level. There's quite a lot to this, but it is doable if you take your time. Got to keep the greasy biscuit fingers off the circuit board. You're not wrong. So we'll hopefully get to that point tonight, right? So we've exported the Gerbers. What's next? Okay, next up, we need a different package. We need a different software package to help us through the next stage. And that is an application called FlatCAM. So let me just go ahead and launch FlatCAM, and we'll bring that up now. Making you want to mess about in KiCAD for no reason at all. Get people messing around in these applications. The vast majority of these are free or freely available. Obviously, Fusion 360 that we use to do this, the circuit design, isn't free, but you can get a personal license. I have a video on that if you want to check out my video section. Obviously, not during the live. If you're watching this on the VOD, if you check out my Fusion 360 video, it'll show you how you can get a free version of Fusion 360. Shameless plug. Right. Okay, so we now open up our FlatCAM program, and FlatCAM is a CAM-based processor. Would help if I click the right buttons on my deck here. So FlatCAM is a CAM processor. So you've heard of CAD, computer-aided design. CAM is computer-aided manufacturing. And effectively, this is a translation application. It translates our 3D or our digital designs and turns it into something that a machine can understand to fabricate it, be that a CNC lathe, a CNC machine, whatever that might be, right? You can make a small board from 120 volts to 12 volts to power a heater controller for your resin printer. That's totally doable. That is totally doable. Okay, so we're going to import our Gerber files. So we go into File, and let's see here, one moment. I just need to make sure that this is going to open the way I want it to. It is not. Give me one moment. Many moments later. Okay. So all I've done here is I've clicked on Open, Import Gerbers, and let's go to my Gerber file, and I'm just going to select all of these files, and I'm going to open them. And here is the Gerber file. So these are all vector drawings of the circuit layers, and we've got edge cuts, we've got a mask for when we put our solder mask on, we've got the actual traces, or the CU. B represents the bottom, and B silk screen, the bottom silk screen. Is this for the pick and place machine? No, it's not actually. But in theory, the pick and place machine could be used in the resulting product that is being designed here, right? Maybe next Mesopotamia with KiCAD could be the $1 million project we all dream of, right? You never know. You never know. You never know what your next idea might come up with. So what we're going to do ultimately is to run this through a CAM processor, and we're going to do some isolation routes on each of these to get some files that we can then export. So I'm not going to do each one, but what is needless to say is we use the tool option, and we choose isolation tool. And I'm just going to use the defaults here. Going to hit the generate geometry. And what that now does is it gives me the geometry of the edge cuts. And I'm going to go ahead and do the same for the circuits as well. Select it, tool, isolation, and generate geometry. So now I'm going to turn off all of the plots. Some people said I never had the plot to begin with. But let's disable the plots. And we're left now with the traces. Now, the reason that we've done this, we have taken our Gerber files, which are vector files. Those vector files are very thin lines, which are actually quite fragmented. And when we bring them into a package to build the design for the 3D printer, it doesn't understand the width of the line. So what we needed was the outline of these traces, not the center point of the traces. So this is what this has given us. So what we would do from here now is to export each of these pieces of geometry into a DXF file. So we export via DXF, and we send out via DXF file because DXF files have measurements in them. SVGs do not. So it's quite important that we keep having like a consistent measurement system in place, right? So that we get the scale correct. Next up, we go into Fusion 360. And let's fire up Fusion real quick. And then we'll get into the actual setup. We're almost there. Design a pocket motor and circuit for industrial equipment. Yeah, it could. That's that $1 million project, is it? Is that what we think? Imagine owning a pick and place machine. I know. What could I possibly use that for? Use FreeCAD. I mean, I really like what FreeCAD is trying to do. In that it's a very capable open source CAD program, but the user interface is, oh my god. Type. Oh, my brain hurts. So, I mean, yeah, there was a couple of projects that I saw that were hopefully bringing FreeCAD's UI up to a more usable standard, but the problem was that project fell through, from what I understand. So, anyway, we're not going to go down that rabbit hole tonight. We've been down that rabbit hole in previous lives, so it has grown up, and I should really revisit it and give it a fair crack. In fact, I actually have a good use case to go back into FreeCAD, because I built the Lumen PMP from source, and I actually designed my own drag chain setup, which is a kind of hack. It's not particularly great drag chain setup. So what I really could do is the latest version of the Lumen PMP source has some components that are specifically for a 2-axis drag chain. So I should go back in and just revisit it and see what that's all about. So anyway, Fusion 360, that's where we're at right now. So we bring in the drawings of the circuit, and then we extrude it to a set height. And this is going to be, your mileage is going to vary. So when we get to the resin-based printer section, we have to figure out how many layers we have, and two, how long those layers are going to be exposed for in order to yield an overall exposure time. We don't want to run the printer permanently on with its LED, because I think running the printer's LED for minutes on end is not designed to do that. So first and foremost, we're stressing the machine. Secondly, I think the LED array actually loses performance the longer it is on. So that shutdown time to let it cool and then fire, I think the strengths of the UV, and this is a theory, I've got no proof to back this up, I think the strength of the UV is at a peak, and if you run it for a period of time, it then just falls off a cliff or starts to degrade over time. So I think that was one of the variables that we were struggling to overcome. There's a lot of variables that we've had to play with and lock down so that we can hopefully get a usable result. You use FreeCAD because that's the program that you learned on, and I'm not going to shame anybody for using whatever program, okay? I don't judge. And some people say, oh, you're a fanboy, blah, 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 blah. Right, okay, I don't care, to be brutally honest. If you have a CAD application that works for you and you get the results that you want, use it. I'm not going to try and convince you to do something other than that, because I'm all about you getting successes, right? So That's the kicker, right? So yeah, if you use FreeCAD and it works for you, you go for it. Let's have a look. It's best to use the machine in that way it was programmed. Also, better for all the machine parts. Yeah, let's. Every tool's not a hammer. If you know that reference, you know what I'm getting at. So yeah, use it as it was intended to be used. How many millimeters on the pad? Okay, so let's have a quick look at that. I gotta remind myself. I think we're 2 millimeters, if I'm not mistaken. But I will double check that for you now. So we'll hit I for inspect. I'm going to select the top surface. I'm going to select the bottom surface, and this will give us a measurement. Oh, we're 1 millimeter. We're 1 millimeter. So cool. So we'll figure out how many layers is, like, how much time do we want to expose it for? We figure out how many layers there are, multiply that by the number of times, and that gives us the layer time. So I've got a little spreadsheet that I've got for that just to help me with the math, because my brain doesn't do math very well. I know formulas and things like that, but you know, trying to actually do the mechanics of math in my brain, it just doesn't work. Could you apply the UV film, then laser it, or something like a plotter cutter, or does the UV film not work like that? So the UV film is quite gummy. It is, it's in a protective coating front and back, and you peel the side off to apply. And then once it's on there, if you were to peel it off and try and use a vinyl cutter, then one, you've got to try and get a FR4 copper-clad board into a vinyl cutter. A KiCAD, something like that, might do it, because I believe they can handle quite thick, you know, varying sizes of material. The question is whether the drag knife is going to be able to get to the level of resolution that you need, whether that's a drag knife or some sort of cutting tool, right? Layer height, are we going for in the slicer? 0.05 millimeters, 50 micron. I mean, we can change that up, right? Whatever. But I'm trying to lock the variables down, because the more variables you've got that can move, the more things you're not in control of. So I'm all about anchoring my variables as much as I possibly can, so that the variance is contained, shall we say, to a small group of things that can change. I can experiment. No, I'm not going to experiment with that. But yeah, thanks for the suggestion. Right, okay, so we extrude that and export that as an STL, and then we bring it into a slicing application, right? So let's bring up our slicer, because we're going to need that, because we're going to need to work out what our exposure level is. I think, looking at my last attempt, which failed, I think I was still slightly overexposed. Only slightly. So the two critical factors for us to get a successful etch, one is the application of this film needs to be flawless, and secondly, we need the exposure time to be zeroed in. So that's going to be our challenge. So let's look at the exposure time first, and then we can prep the files, and we can get going on the important stuff, because you guys want to see this etch, right? You guys want to see whether or not I can actually get a usable part. So we're going to add our files. In fact, let me just quickly go here. Oh, that's fine. That's fine. So actually, it's not fine, because I think Where did I put that file? Ah, I put that file there. All good. All good. I'm being a clown. Don't worry about me. Okay. So there is our file. The first thing we have to do is make sure that the artwork is orientated correctly for the exposure, because otherwise we're going to have a circuit board that's backwards, and that's no good for anybody. So we're going to rotate, and in the light key slicer, we use the rotate option, and then we choose on plate. Okay, we select the surface that we want, and then you'll see the board flip, like so. There we go. So we're now orientated the correct way. The next thing we need to do is figure out what our exposure time is going to be. So let me just grab my spreadsheet. Almost there. I'm going to grab my spreadsheet. Okay, so here's my spreadsheet. Should have at least, should have at least about 20 layers. Well, we'll see, right? So, just a quick calculation. Like I said, my brain's not the greatest mether, right? So that's why I've got this spreadsheet. So 3.3 minutes is where we're at. 200 seconds. I think 200 seconds is slightly over. I think I want 3 minutes. So if I just change the time per layer to 4 seconds, we can just play around. 2.6, I think that's a bit too low. Okay, how many layers have we got? So layer height. Let's do a quick calculation here, right? Layer total number of layers. Okay. So we are 1 millimeter. Our layer height currently is 0.05. And if we say that layer, that is equal to that layer divided by that layer, and return. Is that right? Okay, let me just check the dimensions that we've got going on here, because things aren't looking quite right. So if I scale, it is 1 millimeter in thickness. Okay, so if I go to export and we change it to our fictitious so 50 micron. Did I run that once or twice? Now I'm second guessing myself. Dang it. Right. So we're looking at, let me just grab the file. I'm going to grab the file that's on the printer, and I'm going to see how many layers it's got, because that is baking my brain. So let's remove the VAT. I have actually been doing some printing. I recently replaced the FEP sheet in this machine. It's the first time I've actually replaced a FEP sheet, and it wasn't that bad. I found it relatively straightforward. So let's fire up the machine, and let me see how many layers that this last test job had, and then we can figure out okay. 40 layers. So that's got 40 layers. Good. So whatever I've done, I've kind of messed things up, right? You can help me third guess myself. Well, thank you, Build Over Bot. I appreciate that. I appreciate the clarity third guessing myself will bring me. How are you doing, buddy? How are you doing? Well. Right, so it is 40 layers on that. So that must have been 2 millimeters high. Ah, yes, yes. Yes, yes. I know what I did. I now recall what I did. I increased the layer height by doing the following. I realized I'd messed up. I've slept since then, right? So I went into layout. I went into scale. I turned uniform scaling off, and I turned this into 2 millimeters. So I doubled its thickness. So there's now 40 layers. So if I increase the layers a little bit more, I'm going to be able to increase the resolution a little bit more. So if I go to 3 millimeters, that's going to give me 60 layers to play with. Okay, so let's go 60 layers. Now, I want a roughly a 3-minute window. So that simplifies things, right? I can do a 3-second exposure per layer, and we'll get a 3-minute exposure time. Perfect, 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 perfect. That is exactly what I want. How am I doing PCBs on the resin printer? Well, that is what this stream is all about, Build Over Bot. We are taking a copper-clad circuit board, or a blank copper-clad board. We're applying a UV coating to it, and then we're using the resin printer to expose the UV material, much like you would in a resin printer, but instead of getting a solid layer, we're exposing the circuit design on this material. We then develop that, and then we we develop it, and then we etch it in acid. So depending on the machine, that could be a good deal. You'll need to check that out. I have the first layer set. It's the same amount of time for the whole print, right? So the burnt-in layers and the extra layers, they're all the same, right? This is an oldie but goldie. Alt F4 will fix it. SWK, welcome in, buddy. Hope you're doing well. Good to see you. Okay, right. So we now need to just finish up our setup here. So we've got 3mm, giving us 60 layers. So we now need to update our fictitious resin. Let's go in here and let's address Yule's comment here about the first layers. So when you do a resin print, the first layers that touch the build plate, they are overexposed on purpose. They want to be as rigid and as hard and stuck to the build plate as you possibly can. In our case, being a fictitious resin, we don't need burnt in layers. So we said the number of layers is 1, and we're going to set that to 3 seconds. And then exposure time over here for the remainder of the layers, we're also going to set to 3, and then we're going to click on OK. And that should give us a 3-minute exposure time. We was exposing like 18, 20 minutes in the previous tests, and that was because the material that I was using is old, and the outer portions of the of this UV coating looks like they've gone bad. So we're now into the good portion. Will a laser be faster? Do you mean like a fiber? Do you mean like a fiber laser in terms of like abrading the copper? Okay, anti-aliasing, we're going to turn on and we're going to sharpen the details. Let's export the slice. So yeah, Builder of the Bot asks, would a laser be faster? Builder of the Bot, do you mean like a fiber laser, or do you mean like a CO2 laser or a diode laser? What? Because there's different grades of lasers and they have different uses. I've tried this sort of thing with a CO2 laser, and yeah, it's not gone well, shall we say. Right, okay, let's go PCB. We'll go PCB number 2. Okay, so there we go. We're outputting. Thinking about a UV laser? Yeah, I mean, I don't have one of those, so I'm unable to verify that or experiment with that. So, yeah. Okay, that's saying it's 5 minutes. What did I... Okay, what did I do wrong here? That's not right. Okay, we got 2 seconds light off delay. So that's where the time's coming from. Okay, okay. Yeah. Yep. Yeah, exactly. I do. I don't know if they go well on the market though, right? Okay, we're gonna go with that. We're gonna go with that. Right, let's get the printer set up, and then we can start talking about the application of the application of the UV coating. Right, okay, so I have 3D printed this jig. It essentially takes or replaces the vat. So we'll pop that into the machine, and we will screw down to get that to lock into place. And I'm going to screw down until it gets into the little divots, and then I'm going to push it forward, tighten down, and then we are good to go. That's not going to move, and that gives us a consistent platform to put our circuit boards against. The next thing I'm going to do is remove the build plate, because we don't need that, and that's just going to end up crashing into our circuit board. So we don't want that to happen. And then I need a spacer so that my circuit board actually fits in the right spot. So I'm just going to put this little guitar pickup flat just in the corner here, just to get an offset. So that's done. Machine's ready. It's now time to get the board ready. And if you've seen this before on the previous streams, you're going to see it again. But we're going to get a fresh FR4 single-side board. So right. Yeah, we're living in the future now, right? Maybe they'll figure out how we can grow those things back. Right. So this is just a plain uncoated copper-clad circuit board. So we need to prepare this so that it will receive the UV coating. It's in a black bag for a reason. We want to keep light away, or UV light specifically away from it. And then we have this little blue roll, and we've used quite a bit of it to this point. I'm just going to trim off the excess, but ultimately I had a bad section that degraded over time, and now we're getting to the good stuff. So we're going to be applying that in a minute. I'm going to put this back in the bag because we're gonna start working on this FR4 board. Now, before I used 120 grit sandpaper to key off the surface of the board, and I think that was a little bit too aggressive. So what I've got here instead is some steel wool, and steel wool we can use to polish, if you like, the surface to remove any imperfections and just prepare the surface ready for us to apply the coating. Now I will be wearing gloves for certain parts of this process and not for others. And I'll explain why I'm wearing them for some parts and not others in a second. So all we're doing when we're using this steel wool is we are polishing the surface of the copper. The idea behind this is we want to remove any oxidation that exists on the surface, because an oxidation layer between the UV coating and the copper itself is going to cause a barrier. So it's not going to bond properly to the surface of the copper. So we want this to be as clean as possible. Now, I am not wearing gloves right now because in a moment we're going to be using some sellotape, and trying to wear gloves and use sellotape is incredibly difficult. So I do run the risk of putting fingerprints and oils from my skin on the board. So what I will do is I'll handle this via its corners as a way of limiting the area of opportunity for me to get my greasy meat paws all over this prepared FR4 copper-clad board. So we're going to make this all as shiny as possible. We do not want the application of the UV coating to be the reason why we fail. Because that's like, yeah, not good. Right, we got steel wool shavings now all over my bench. Awesome. I'm going to come through with a magnet just to get rid of any bits and pieces that remain, of which there's quite a bit. Oh wow, that's quite a bit of debris. All right, so that's our FR4 board. Now I want to remove any fingerprints that might be on here. Quantum agitator gets put to the oxidation. Trying a sandblaster. Right? Are you guys like trying to set me up for a failure? Are you guys trying to help me or hinder me? Huh? Okay, so I am using 99% isopropyl alcohol. So that's what I'm using. Yes, I know it's a big container. I know. Okay, so I'm going to pick this up. I'm going to hold it by the corners, and I'm just going to give this as much of a clear out as I possibly can. You can see there's dirt, and I've saturated this cloth to get the oils dissolved and removed from this board as best I can. So this is the part of the process I will not be wearing gloves. You set up in there? Oh, thanks, Bill, about. You know who your friends are, right? Who your friends are. Yo, I agree. We need a setup for the win. There's no point playing games that you're always destined to lose. You've got to set yourself up to win. Right, I'm just going to plug in my laminator. We're going to use a paper laminator in order to do the application. Okay, so I'm still not wearing gloves, okay? The reason I'm not wearing gloves at this point is because the chemicals I'm using, they're not particularly harsh, and so I can see something on this board. Is that oil off my hand, or is that just some IPA residue? Okay, cool. It's gone. Yeah, so I don't particularly want to fight with a glove because of tape, right? So that's not where we want to be. Right, okay. So we're going to cut this UV coating a little bit oversized. I'm going to place the board on here just so I can figure out how big I want to cut. And for those of you who like straight cuts, you're not going to see that from me. Okay, we're just going to slice that away, like so. So this material that we got here, right? It looks like just one sheet of film, but it's actually three. There's a front coating, protective coating. There's an inner core, which is the UV sensitive stuff. And then we have a rear coating. Front and rear, you pick which is which. But yeah, we need to now remove the one of the protective coatings to expose the UV material to the copper clad board. So I need my trusty sticky tape wherever I put that, because I am very organized, and you know that's not true. You know that's not true. It's probably just staring at me. It's probably on the bench just saying, I'm here, and you just, you're just too much of an idiot to see it. But, yeah. Where did I put the tape? That's just crazy darts. I am a little bit bamboozled. I've got a workshop gremlin. They have stolen my tape. Does anybody else have workshop gremlins? And I'm going to turn back, right, and it's going to be like just there. I got it. It was on the tape. See, workshop gremlin. It was a workshop gremlin, I swear. Right, okay. Now I can see particles on this board. So I'm just going to, do you know what? I'm going to give that another IPA wipe. Because, I don't know, maybe I'm paranoid. But we're going to do an IPA wipe. We're going to try and do this as, we're going to be as friendly as we possibly can while wearing naked hands. All right. I'm not worried if I get like oils in the extreme corners, because there isn't any circuitry there that's going to be susceptible to that being a problem. Okay, so that's done. We're going to move quickly now so that they don't get any. Oh, seriously? I suppose rather than using tissue, I really should use like a lint-free cloth. Maybe that's a thing to invest in for future. Okay, we're gonna go for it. I see what you did there. SWK. If only it was an Indian Pale Ale, right? If only. So IPA, for the uninitiated, is also an Indian Pale Ale, which is an alcoholic beverage. Which we are not using here. But if I used beer to coat my board, then yes, it probably would be sticky. Okay, what I'm doing here now is very much, if you've ever tinted a window, you'll know when you put the coating on, if you're not careful and you don't squeegee it properly, you get air bubbles, and we definitely do not want air bubbles in our application here. Definitely not. Right, I'm going to use this Post-it pad as a bit of a squeegee, right? I'm going to squeegee away. Okay, we're going to need to reapply because we just scuffed the material. I'm not willing to accept that. Okay, start again. This application has to be perfect, because if it's not, it's going to lead to problems. So this is where you take the time, right? If you've rushed previously, this is where you take the time to get this portion correct. Use a credit card for a squeegee? Yeah, the problem with credit card is it's quite an aggressive edge. You can actually buy squeegees if you're in the sign making business. They actually sell squeegees, and they are purpose made for that particular job. And you'll notice I'm not going to the edge of this material, and the reason for that is that we do know that the edge has been exposed previously, or certainly earlier in the roll it was exposed, so I'm staying away from the edges because I don't trust the material. Right, okay. Alcohol wash. Oh, see where we were going with that. Thank you, SWK. Do both sides so you can get my number and my security code all in one. Yeah. Well, I might live stream, but I don't, I don't make the big YouTube bucks. I wish I did. I wish I did. I mean, I don't have a big enough following to do super chat responses only, right? Yeah. Alrighty. Let's try that again, shall we? So we need 2 pieces of tape. We put the 2 pieces of tape on the sheet in opposing in one of the corners, and by virtue of removing the tape and pulling, we remove one of the protective coatings, and then we apply the film that side down onto the FR4 board. And we picked up something. What have we picked up? There was static build up, and it attracted some fluff of some kind. I think it was off the I think it was off the tissue that we used just to clean this a moment ago. Right, I'm just going to get rid of this tape because that's going to... Do I leave it? Do I leave it? Oh, my word. Choices, choices. Okay. I'm going quiet because I am concentrating incredibly hard to get all of the bubbles and any artifacts off this, because like I said earlier, I do not want the application of this film to be the reason that this fails. I want to remove this tape if I can. Just take my time just for a second to get this tape gone. Come on. This tape really doesn't want to come off. Do it. Do it now. Here we go. We're getting there. Slowly but surely. This is a real-time experience. Okay, I can see air bubbles, so let's see if we can eliminate those. All right. Right, so the next thing we're going to do is we're going to run this through the laminator. So the laminator is going to heat up the copper board, and it's going to cause this UV coating to bond to the copper. And then we're going to inspect it. And I'm hoping when we inspect it that we actually get a good application. Okay, I'm going to go one more on this, actually, because I can kind of see some air bubbles, which I am not too happy about. I could be overthinking this incredibly, right? But Okay. So, piece of copy paper. So we're not having a $1 million giveaway. No, no. So we create a little pocket. I always have the folds to the edge. Not in the. I'm not going to insert this into the laminator this way. I always do it this way because I've found in the past that this fold can cause a problem with the leading edge and can cause things to wrinkle. So what we did find is that by a single pass through the laminator should be sufficient to bond everything. So let's get it through, and then we can get on to the exposure and developing of the board. So, alrighty. Let me just quickly catch up on chat. Let's have a look. Finds. You can find them where they sell cricket stuff. Yes, I'm guessing that's in reference to the squeegees. Usually the outer wrap that gets exposed. Yes, so it's the protected side that will get exposed. The exposed side goes down onto the copper. There we go. All right. So here's the question: did I apply that good enough? Okay, there are a few artifacts in here, but we're going to run with it. We are going to run with it because I'm very conscious of time. But it's bubbles. It feels like air bubbles. So we might want to orientate this in a way that that's not going to be a problem if we can. But my confidence factor in us getting a successful exposure and etch has just slightly gone down, simply because of the application of this film. So this method is pretty tricky, right? This method is pretty tricky, to say the least. Right, okay, let's just give that that was a coarse trim. Let's give this a fine trim to get rid of. See, this is the beauty of YouTube Live. You're seeing this as I'm doing it, right? There's no do-overs. There's no edit button. There is no keep doing it until you get it right, and then say first try, right? So you're living this problem with me. So let me get my Sharpie. I'm going to put a reference mark on here. And that reference mark, we've got markings on the back of this board. I don't know if you can make those out, but it says DE on the back of the FR4 board. And I'm just going to put a dot in the bottom corner. I'm going to use that as a registration to say what is the bottom left corner of the board, right? And then whenever I take this off, if I go ahead and do a solder mask later on, once I get a successful etch, we will look to use that registration mark to be able to realign with the resin printer and get all of that stuff, right? The outer wrap of the roll gets exposed to UV light, making it not useful for film. Yeah. Yes. Yes. So that was me reading that comment out of context. All right, so let's get this in the machine and exposed, and we'll find out whether or not we've done a good job or not, right? So in the machine, register it all the way to the left, all the way to the bottom, and then we just refresh our job list because we took that out. That's PCB 1. We're looking for PCB 2. There it is, PCB 2. And then we're just going to hit the run button. And that's going to expose 60 layers. Just make sure that is all the way down, all the way to the left. And that's now going to use the UV light in the printer to put our artwork onto that board. So now we've got that underway, I guess what we really should do is start preparing the developer. So I disposed of the developer from the previous attempts. So we're going to mix up a new batch, and we'll get ready for that while we're waiting. So essentially, we've got a plastic food tray, and I'm going to put in some just regular cold tap water into the unit. In we go, like so. I don't know whether warm water speeds things up. It might. It might not. And then what we're going to do is we're going to get some of our oxy bleach. This is a fabric bleach. It's a non-aggressive bleach that goes into, or stain remover, not bleach, but yeah, you put this into laundry, and it removes aggressive stains. That's really really cool, because it means that this stuff is readily available. And we just put 1 scoop in here. All right, that's done. And then we're just going to mix that up, dissolve it. This can like crust up, so we'll just make sure we dissolve it as best we can. Might put some more water in here, but so yes, what this does, when you place the exposed circuit board and you remove the second protective coating, the UV material gets exposed to this, the chemicals that are in this stain remover, and it causes the exposed areas to go hard and solidify, and the unexposed areas dissolve away, leaving the copper board. So that will then allow us to drop in, it so effectively creates the mask. We then drop that into ferric chloride and etch the copper away. So the removal of the mask is quite important. And once we've removed the mask, we'll do an inspection of it to make sure it's removed properly and that we haven't overexposed things. And we've got good trace separation. And that'll tell us if we've got a good chance of getting this etched out correctly. We're gonna go for this. I'm confident. Let's have a call out in chat. Do you guys think this is going to be successful this time, or do you think it's going to fail? It would be good to know what you guys think. So one way or another, I've got to get working on this prototype this weekend. So this board's got to get done one way or another. I think this won't be the last stream trying it. Okay, so we've got one person. Well, Riley Race, you think it's gonna fail? I know the process works. It's about proper application. Yes, I concur. Okay, I think the water is now saturated because we're not dissolving anymore. So I am going to just add a tad more water. Just to see if I can get the last remnants of this to dissolve. I don't want any particles because I don't want any of that to land on the top of the surface of the board and behave differently. I want a consistent approach, right? Yeah, for the problems that you think it will work, but you're here for the problems. The Yule things is good because we know the process works. It's about getting the application on point, right? Yeah, that's a big one, right? So the other issue is I thought why it's different than using a normal UV light is the LCD screen may block a certain percentage of the luminance. Yes, it does. Yes, it does. However, that's I mean, it's sufficient enough to cure UV resin, right? It is designed to cure UV-based resin. So the theory in my head is that, yeah, it should cure my circuit then. That's always an option. That's always an option, right? I mean, I'm asking whether you think I'm going to get a usable circuit out of this. I mean, we can check the exposure times using just a standard resin. Let's have a look. Using Elegoo resin. I've got 14 seconds exposure time. And that's typically not been our problem, right? Our problem's been that we've been overexposing. Right? We've been overexposing. The more some from China try to see what I made earlier trick, 80s TV program, right? I'm not going to fake it. If it works, it works. Bill, you think it's going to be usable? Thanks, buddy. Yeah, I don't want to fake it at all because that's it's something I want to show someone a usable process as opposed to faking it and trying to get the clickbait. I want to be known for integrity. I want to be known for integrity. Right, how far in are we? We are currently 45 layers out of 60. So that's not going to be long for we're going to be attempting to develop this circuit board, right? So there's the print as it is at the moment. Yeah, that's I'm not going to do that. No, I'm not going to do that. I don't want to do that because, like I say, integrity. I want to show some. I want this to be a one shot, right? I want this stream to be a one shot, so that people can see if they want to take this process on. This is what you're dealing with. Yeah. You don't know. I think there's some creators out there who are pride themselves in integrity. There's a lot of different content on here, but it's not what I'm going to call my circuit board company, Integrity. I mean, maybe. I don't have plans to have a circuit board company right now. So, I guess all options are on the table. Yeah. This is the internet. I'm not sure integrity is the goal here. I don't know. It doesn't sit right with me. Oh, no, I wouldn't say that. I wouldn't say that. Right, how far in? How far in are we? We are currently at 56 of 60. We're real close now. We're real close now. Last couple of layers. Okay, I think this is the last layer. It's got a weird numbering convention. It'll go down. It won't display anything, but then it'll just come straight back up. There we go. We're done. We are done. Okay, where are those bubbles? Where are those pesky bubbles? We do have one. Yeah, we got one trace that's in a bubble. So we may have issues with this, but we're going to press ahead. Okay, so there is a circuit board. You can just make out. You can just make out that that circuit. Okay, so let's bring the camera over, and we'll get a shot of this. I don't need more squirrel moments. I don't need more squirrel moments. Okay, so here is the circuit. I don't know if you guys can kind of, it's so difficult to get, I mean, with studio lights and what have you, it's so dang reflective. Can you guys make out that circuit? Just, okay. So we're going to remove the plastic coating that's on here by sticking tape down and then peeling the coating away, like so. And then we're going to just drop this in, and hopefully we should see the circuit board appear as if by magic. You can almost see it, right? All right, so what we're doing here now is we're developing the exposed circuit board, it should become more and more clear as the unexposed material gets dissolved. Yeah, the application is incredibly sensitive, right? So we may have to do some touch-up work. Right, I'm going to bring in a little brush and I'm going to just scrub away. Yeah, I'm starting to see copper getting exposed here. I don't know if you guys can see that as well. Now, I can see where there's been bubbles. Oh yeah, we've got touch-up work that we're going to have to do. Okay, let's turn that around. Yeah, definitely going to have to do some touch-up work before we put this anywhere near the acid. So that's a shame, but I mean, I suppose with this, with the variables that I've got right now in terms of the quality of the UV mask, the application, all that sort of stuff, you know, there's any number of issues, right, that we're dealing with. Okay, so those pads still need a good clean, because this is one of the problems that I had on the last attempt, which was these pads that I'm scrubbing right now. They were shorted, so okay. So I'm just going to get a water bath set up so that I can just rinse this off. And then we'll dry it, and then we're going to have a look to see where we need to do some touch-up work. Because touch-up work we need. Okay. Let's just quickly take this out, and we're going to dunk this into some water. Just clean water. Just dilute that. In fact, I don't think that's going to be enough. I'm going to put this under a tap, a running tap. 1 second, guys. I'm just stepping away. I'm going to leave the mic hot so you can hear everything. And what I'm doing is I'm just rinsing this just to make sure that the mass that we do have kind of stays intact as best I can. But we do have broken traces. We do And this is all down to the application. So this process I think will work, but it's just so dang finicky. Yeah, let's just drawing off the board. Who knew off-camera streaming would be a thing? Well, it is for me. Okay, so I got two choices. I either try another application of this, or we YOLO it. Okay, let's have a look under the microscope and see how bad this actually is to determine whether or not we start again with the application, which would be a bit of a shame if it is, because I need to move this forward and you don't want to keep seeing me doing the same thing over and over, right? So we need to progress, as it were. Right, let's get the microscope. Get the microscope up and running. Yeah, I did. So you've got a YOLO. Bill of a ball wants to YOLO, right? Let's bring in the microscope. And we'll have a look at this and how bad this actually is. I don't think it's particularly great, to be honest. But we shall see. Where am I? I want... that. Let's fire up the microscope. Oh, man, that's pretty bad. That is pretty bad. Not good. Not good. Okay. Okay. Let's get us back to here. Let's get a little light on the situation. Okay, so we've got quite a few bubbles. We've got a broken trace just here. A trace that's like damaged there. Completely gone trace there. And this is all because of bubbles, right? All right, so this is the bit that I was interested in. Everything we got going on kind of rides on how well these traces here. Yeah, not like a clown, I actually caught the blade on here. Yeah, that's pretty bad. So, you guys decide. Are we going to try this? Are we going to try and repair it, or are we going to reattempt an application? A reattempt of the right. So, if we're going to go forward with this, I'm going to have to patch up these with a marker pen and hope that the marker pen resists the acid. The alternative is that we remove the UV coating and we reapply and hope that we get a better result. But yeah, that's pretty awful in my book. Yeah, I think that's too... honestly, I think that's too far gone. I think that's too far gone. So I think what we need to do now is to make up some of the etchant removal, which is caustic soda, sodium hydroxide. And we'll mix that up and remove it, and we'll reapply. Get it nail polish. Yeah, I don't think that will go down well. But yeah, let's remove that and reapply. That is a darn shame. So I used isopropanol to wipe over the circuit board. I think this time I'm going to use acetone. I think if I use acetone, that's a little bit more of an aggressive cleaner than IPA. I really should be wearing gloves at this stage, but I'm still not. Don't do as I do, people. Okay, so we're just going to dissolve this sodium hydroxide. Okay. Yeah, that's a thing. Okay, so now I am going to glove up at this point. So let's grab some gloves, because I will need to retrieve this board from in here once it's done, and I'm going to need to wash it, dry it, all of that sort of good stuff. Sodium hydroxide is nasty stuff, right? So shouldn't be taking chances with this stuff. Use proper handling techniques with this material. Okay, now we're all gloved up. Let's turn on. Quickly need to. Okay, if I go here. Nope. Nope. That didn't work. That didn't work, now did it? Why is that being like that? Ah, that's why. Being a complete doofus, that's why. Okay, there we go. So this is actually quite interesting to watch. This stuff is acid resistant, but it's not alkaline resistant, and caustic soda is alkaline. So when we pop this in here, we will see this break up and do all sorts of crazy stuff. Pretty mad to watch. Okay. Yeah, so what do you guys think? Do you think acetone would be a better option for cleaning the board versus isopropyl alcohol? I'd be keen to hear your thoughts on this. Okay, watch this. Watch closely. Watch closely. In fact, let's... This is crazy when it starts happening. But the exposure time looks good. Okay, so I can confirm the exposure time looks good. It's just that dang application. That is such a pity. Here it goes. It's starting to go at the top edge, just up here. It's fading. It's a mechanic you keep your own nail polish. That's pretty funny. Okay, there's still stuff on here. Is that going to come off as I... It's pretty on there. It's faded to a clear coating. Don't know how much of that you guys can see, but it's turned into this clear gel. Okay. Right, so now I'm going to quickly douse this in some water, and then I'm going to rinse it under a tap. So I will be stepping away again, unfortunately. So let me just quickly grab this and dunk it in the water bath that I've got. Bosh. And it goes. Okay, that should be enough to dilute it down. Now I just want to go and rinse it to get the worst of it off. Right, so it's that. The surface cleanliness and the quality of that laydown of the material is what is kicking out bets right now. Which is incredibly irritating. So I don't know how much of that is like me and surface preparation versus the material is junk, right? The UV coating is junk. Right, okay, so that's that. So let us... I'm going to keep the gloves on from here on in, regardless of us having problems with the sticky tape for the application. Yeah, in a couple of days' time, we wonder why there's holes in my floor mats, right? These chemicals are not nice. They really are not nice. Right, gloves staying on. Okay, so the first thing we're going to do is steel wool, wherever I put that. Workshop gremlins again, Let's move this camera out of the way. Oh, I see the steel wool. I see the steel wool. Okay, so we're going to steel wool the surface. And we've got like corrosion and weird marks now from where we had the circuit board, the UV mask. Okay. So now we're going to pick up all of the junk with the magnets that's on here. Just some neodymium magnets on a bracket, really, that I'll clean off later. I just don't want there to be particles on this workbench. Okay, so now we're going to go with acetone to clean the surface. And I'm actually going to change my registration mark because I've scored the copper board with the knife. I think I've created a crevice that acid will be able to get into, and ideally we don't want that. Right, so I need to be careful with acetone because acetone is a lot more volatile than isopropyl alcohol, to the point that you can dissolve like polystyrene, ABS plastic, etc. One of the things I used to do in my early 3D printing days was to use acetone to make ABS slurry as a print bed coating. So you just need to be careful with acetone. So it's a little bit more aggressive. That's good to the electrolytes. Acid was good for your skin. Oh my word. You guys are the epitome of bad advice right now. Like, what gives, guys? What gives? Right, I need to move some bits around here because otherwise I'm going to get myself right in a pickle. And not a good pickle either. Right, okay. So I've got a score mark just here. So I'm going to put that to the left. Like I said, I'm going to swap the sides because I don't want that over my circuit any way, shape, or form. Right, so let's pick that up and clear the bench. Now here comes the tricky part in that I need to cut the UV coating, and then I need to apply it, and I'm going to be fighting with tape with these gloves. But given what we've just experienced, so here's the deal. The fact that I'm doing this again, and you guys are here, whatever the result is, on this next application, we will etch. I do have more boards, so I can. I've got another idea. If this fails, I've got another idea which doesn't involve this material, which I think I'm going to keep for a video idea. But we'll see. We'll see. I'm going to keep that to myself a minute, what my plan B is. But yeah, I definitely think some of this is repetitious practice. That when you start applying this material, and you get into you would get into a rhythm. Would I want to apply this to circuit boards for like double-sided? Oh my god, can you imagine this being the double-sided process? That would be an absolute nightmare. Right, so I am already fighting with this glove and the tape. Oh, dear God. Get off. Okay, let's make the tape as small as possible, and then the contact area is reduced. Oh, and you're going to like be an absolute douche. Okay. Okay, that's not bad. Is that a bubble, or is that some weird bubble artifact? What is that? There is something on the damn board. Oh my goodness. Are you kidding me? Okay, that's much better. Okay. Much happier this time round than last time round. Famous last words, right? Famous last words. Sorry, guys, I'm not checking chat a minute because I'm so hyper focused on this. Use the squeegee, don't do it with your finger. It looks like a better application. Yes, 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 yes. It is a better application. That is much better. But the question is what is that going to look like the other side of the other side of the laminator? So only time will tell, right? Only time will tell. Okay, here comes the laminator. And through we go. Not mess around. All right. Oh, this is a bit of an ordeal, right? All for a freaking circuit board. The things we do for our hobbies, huh? Okay. Okay, we've got a good application, but well, should I say we've got a better application? But I am seeing artifacts on the board after going through the laminator. So if I hold that up, can you see like these little dots? There's like little bubbles. There you go. I don't know how that's gonna fare, but it is what it is. It will be what it will be. Whatever happens, this is getting etched. Okay, where's that score line? That score line is there. So we want to change the registration. We're going to put a cross instead of a dot. I just put different registration marks so that that score line is not near a piece of important infrastructure of the circuit. Important infrastructure of the circuit. What a sentence. That is a sentence that I never dreamed that I would just say, but I just did. Who knew? Right, I have got a pot of caustic soda here. Where am I going to put that? Where I'm not going to boot it or yeet it across this workshop. If only I had a dedicated space for all of this, that would be nice. It would be a pipe dream, but yes. Let's put it right next to the acid, because that's a safe option, right? Because if they mix, they cancel each other out. That's what I'm going with, and I'm sticking with it. Don't judge me, which I know you will. Right, okay. Da-da-da-da-da, here we go. Crazy show. Crazy show. We're gonna pop this in here, like so. And we're gonna go, okay. We're gonna go PCB2. Gonna make sure we're registered properly. And we're gonna go for it. Right, so here's the deal. Whatever this turns out, we will be etching it. So I will need to fix any blemishes that there are in the circuit board, right? So what is that thing? I'm catching up with chat. What is that thing? I'm assuming you're referring to the laminator. So the laminator, it's just a regular paper laminator for like laminating A4 sheets of paper and stuff, or pictures or whatever. And essentially what happens is that you put that board with the coating on through the laminator, it heats the board up, and it causes the UV material to bond to the copper. Why do you want to laminate it now? Well, that's squirrel. You're going down a squirrel hole, right? All us makers have them. That momentary distraction that you know, before you know it, you've planned out 3/4 of the way through a project you never intended doing. Right, okay. So, just for clarity, we're going to etch whatever result that we get off the back of this exposure. We're going to etch it. We may need to do some touch-up work. So for that, we'll either use a Sharpie or a marker pen of some kind. So I've got, that's non-permanent. So I don't want that. I don't want you. So we'll grab a couple of Sharpies. And what we're going to do, as I say, when I was in school, in America, you call it high school, right? You know, but a bit before you go to college. I always remember that we, in the electronics class, we were given a marker pen and a copper-clad board, and we had to freehand draw the circuit before we then etched it. Man, it's crazy, right? Right, build over bar, right? See, now this is the problem with being a maker, right? You start talking about side quests and squirrel holes, and man, you just march off into the distance, and before you know it, you're in Narnia. But yeah, I remember, like I say, being given one of these marker pens, a copper-clad board, and a textbook showing you the circuit that you want to do, like an old analog flip-flop circuit for flashing LEDs. Today, you just put in a microcontroller, like an Arduino, and you program it, do the blink sketch, and LEDs flashing, right? Back then, we would use a transistor flip-flop. So 2 transistors, 2 capacitors, and the charge time of the capacitor would then illuminate the one LED, and then once it's fully charged, the circuit would trigger and go over the other side. Just an old analog sort of flip-flop circuit. Crazy stuff. But we would do that with a pen and a circuit board. Not even perf board. Crazy, the things that we used to do. This is Breaking Bad circuit board making, right? Except I haven't got the yellow jumpsuit and the respirator, which I probably should have had the respirator mixing up that caustic soda, because that I took a hit of that, and that was not nice. Report. You want to make a multi-pass. That's what it is. You want to make a multi-pass, like from Fifth Element. Multi-pass. Right, how long are we looking at with this? We're a good way through already, actually, looking at that. We are 38% through. We are layer 24 of 60. So that's good. It's very good. So here we go. So next up, we've got the exposure to complete. Then we've got the developing to complete. We then got touch-up work, because there's going to be touch-up work. I'm pretty confident of that. Once we've done that, we then have the etching and then final mask removal. Those are the steps that we've got. So fingers crossed, by the end of this stream, we're going to have something that I can drill some holes in, put some components in, and we can then start prototyping off the back of this board. But we'll see. You got ideas on your phone now, right? Right. I mean, it's not going to be long, and you'll be speaking to people who do not know what a physical ID is. So I work in IT, and we had a network failure this week for the wireless, and we went around. A couple of guys went around the office telling some of the staff, about plugging in a Wi-Fi cable, and like, sorry, plugging in an Ethernet cable, and they were like, "What's an Ethernet cable? What's one of them?" I was like, "I feel so old." Anyway, I mean, my day job is IT, but our business isn't IT, so you can forgive some people. They don't get employed to be IT. I do. So it's my job to know, not theirs. Anyway. Right, y'all. Multipass. It's the multipass. And I mean, who knows? You could even be Tobin Dallas. Going to Fluston Paradise. I mean, my first foray into IT was first line support for an ISP dial-up, and after probably about 2 months, I could tell what make a modem the user was using. I could tell if it was dialing the right number. I could even tell the baud rate that it was handshaking at. So, yeah, it was a long time ago. And people say, "Oh, well, that's really sad." It's like, well, when you're taking between 40 and 80 calls a day, and you hear the dial-up tones, and you hear you hear the number being dialed, and you hear the tones. It's repetitious muscle memory. Oh, after a period of time, you're going to recognize things. Not because you intended to. It's just by osmosis. You just learned that, oh, that's a US Broadix 56K X2. Oh, there's the bongs. Or it's a Hazer Cura 56K Flex. There's the white. Yeah, crazy. Them were the days, man. I'm so old. Oh, that's just so funny. Right, what are we looking at? We are looking at 47 layers. 48 layers of 60. We're getting through them. We're almost there. So, Sharpies. I'm hoping that these Sharpies are going to be good enough to resist the acid. I've got a couple of different Sharpies. So I've got a regular fine point Sharpie, if that's what you want to call it. I don't know if that is a fine point, but it doesn't look fine point to me. Not when I've got, it's fine point and ultra fine point. So we've got that bad boy, right? And then we've got that bad boy. So we should be able to get some really fine work. And then worst case scenario, we've got another fine point. So depending on, if any of these need an alcohol wash just to get them working, they should all be good. Almost finished. Almost finished. Well, we're on a second application. We're on a second application mode, Rally Race. We've had an issue, right? RS networks. Okay. Explain what you mean by RS. Because that could mean a couple of different things to me. You can get much finer? Yeah, no doubt. This is what I have at my disposal. This is what's in my shop. So here's how it's going to go down. We're going to patch up any gaps. We're going to etch, and then any any breaks that we get in the resulting etch, we're going to put some trace wires in, and we'll fudge it. We've got to move on. We've got to move on. No, I haven't. No, RS 485 and 232. Those like the D-sub connectors, right? I mean, I remember BNC networking. So you had your coax and a T connector, and you had a terminator on each end. I remember those days. Oh, are we done? Yeah, we're done. Awesome. Oh man, we got a bubble. We got a bubble right on the trace. There's no way that is going to survive. No way. But, you know. This is, we can probably refine this process. I mean, if you bought pre coated circuit boards, you can actually buy boards that already have the UV coating applied to them. So if we bought one that was pre-coated, that would probably help this process, because I think the vast majority of my issues now are in the application of the UV material. Right, so we now need to remove, I can take the gloves off at this point because what we're working with isn't nasty, and I don't need to worry about fingerprints. You started at Cat 5. Yeah. Lucky man. Okay. In we go. We've just removed the coating, the protective coating, and it's gone in for its development. In it goes. So that the circuit should become clear relatively quickly. I mean, I can see it pretty well here. I'm not quite sure how well you guys can see it. Now, I'm not going to scrub this just yet. I want this to dissolve as much as possible before I get the brush in. Now, where it's applied well, the exposure looks really good. But it's the surface quality and the application quality of the UV coating is the issue, right? Okay, let's get the brush in here, and we'll start getting rid of this. This is gonna start popping like a circuit board all of a sudden, because as this starts getting removed, the copper is going to start shining through. Go gentle. Don't rub it. Maybe just let it dissolve. Yeah, the trouble is that it can actually dissolve the stuff we want to keep. I'm going incredibly gently here. Okay, I can already see we've got, where I said that there was a bubble on the trace, I can see that the trace is broken. Can see the copper starting to bleed through, so I will need to do a patch job on that. But I am being incredibly careful here. Wow, on those sorts of numbers, you will be ordering from a PCB manufacturing company, right? So that's actually a really good point. Why would I be doing this as opposed to ordering a circuit board? Well, you know, we've started this process. We talked through this process, and we're at the point where we're going to start etching a board soon. And we've been live for what? It's just coming up on about 2.5 hours. So you look at this from a prototyping perspective, that we could potentially have using a circuit board inside of 3 hours. Well, you know, we definitely will have it inside of 3 hours because that first application went a bit wrong, didn't it? So the reality is, if you did it right first time, then you know we would already been completed etching by now, right? So there's that to consider. So in terms of like getting a prototype done and getting us through to actually doing the work that we want to be doing, we could be doing this easily tomorrow, right? Easily tomorrow. Okay, we're getting close. So yeah, it's tomorrow versus waiting a week and a half for a set of 5. Integrity PCBs. Well, do you know what? I have like been curious to the commercial process of making circuit boards, single and dual layer, not multiple layers, like, you know, 4, 5, 6 layers. I am curious as to how that plating process works and whether or not that is something that could be replicated at home. Or what type of machinery do you need to be able, in order to do that? That does intrigue me. Right, okay. Right, I'm going to go and give this a rinse, and then we're going to get this under the microscope, and we're going to have a look, and then we're going to see what the damage is, where we need to repair, and then we're going to go from there. Right, so here we go. Let's go. So the trick's going to be, right, when we test this board out, we're going to have to make sure that we haven't got traces grounded where they shouldn't be. And we also have to be sure that the traces are connected where they need to be. So we will need to do some multimeter tests towards the end here. But again, I'm seeing holes in the board that I didn't want to see, which is less than ideal, but we are where we are. We've got to make this work now. We've got to Tony Stark it. You know when he's in the, when Tony Stark makes the Mark I Iron Man. You know when he's in the cave. Kind of feel like that's what I'm doing right now. Is I'm like, this is Mark I. Circuit board prototyping. Crazy. But whatever, if you're in a pinch, could this work? I've got another, like I say, I've got another idea, which I think may result in a better end product. Right, okay. Let me just clean this up, move this out of the way before I make more mess. Oh my word. Over the weekend, if I get the circuit board working, over the weekend, I will try my other method to see whether or not, if it will work. And I'll document it and maybe do a side-by-side comparison. Right, what do I want to do here? I want to turn my... Let's go back to the microscope. Okay. Let's get this out of the way. For a moment, we will need to come back to it. And why is that not visible? Why is make it happen, right? Do you know what? That would actually be kind of cool. I must admit that does intrigue me. That the whole process of it all, right, does intrigue me. Right, where do I want to go? Let's go to my microscope scene. Oh, there we go. There we go. That's why it's not working, Steve. It's because you didn't turn it on. There we go. Doink. Right, okay. So, similar problem to what we had previously, right? In that, for the most part, it's not too bad. Where it's down, where it's down, it's down. It's pretty good, right? But there are, let me get a sharp pointy thing so I might actually need a sharp pointy thing to clear out some bad traces as well where it's shorted, or would be shorted if we etched it as it was. But so where are we? So that trace is disconnected. So hole there. So yeah, this is all about application. And I don't know how much of this is just the material is bad versus, bad surface quality of the board, all of that sort of stuff. It's like, I need to check my I need to check my schematic to see whether or not that should be joined. But if we look at these pads, they're reasonably well exposed, right? Get a toothpick and some nail polish. Well, I'm actually going to use the Sharpie. So if I like block this out, let's see if I can get you a. So the idea being here is the ink of the Sharpie will effectively block out and stop the acid getting down onto the copper. There is a barrier material, which is the permanent ink of the Sharpie. I don't think so, because looking at the exposure and the quality elsewhere on the board, this is. I mean, we did say before we put this in that it was there was artifacts. You could physically see lumps and bumps in the application. So this is definitely an application problem, right? Applying this to the board and getting a pristine finish is problematic. But I have an idea. I don't know whether to try it now or not. Here's my idea. I'm thinking about getting some UV resin and putting UV resin on top of the circuit board, putting a plastic coating on top, and then putting that onto the machine and seeing whether or not the UV resin will create a resist or whether it will break down in the acid. I don't know what it would do, to be honest. But then it'd be a case of how do you get that off the other side? Surely someone's done this before, right? I don't know whether you can even see what I'm doing right now. Ah, well, you absolute plum. You guys can't even see what I'm doing. Yeah, I have done that in the past with this material. The problem that you get though is as you squeegee it, it ripples and it damages it. It is actually quite fragile. Okay, I'm gonna go one. I think I might try this. The more I'm thinking about it, the more I think, why the heck not? Now, that could be an incredibly bad idea. Or it could be genius.
But yeah, there's a lot of artifacts, like really small. It's almost like there are particles underneath, or has been particles underneath the traces. Like that traces like doesn't even exist. Yeah, there's quite a lot of damage to these traces that I wish I didn't have to repair, right? Well, that's what I was thinking. That's exactly what I was thinking, Yule. One of the guys on Hackaday just puts a UV resin, does the thin layer on top of it, and then puts a release film on it. That's kind of what I'm thinking. So I do have more FR floorboards. So can I have a show of hands in chat? To see whether or not we should try that. Should we try trying to put UV resin and cure that? And we'll do a side-by-side etching. I don't know, Euro. I don't know if it's something to do with the UV, so the surface tension, micro scratches. I don't know. I don't know. Is the answer to that? So I'm having to, like I say, I'm having to do a lot of patchwork here. So I'm just going to quickly just go through my traces here and just make sure they are as intact as I can possibly make them. I mean, right now I'm tempted at just getting some breadboard on Amazon and oh, dang it. Yeah, I'm tempted on getting some breadboard from Amazon and just using enameled wire and hand wiring this damn thing. Because this process should work. The concept of this process is sound. But the problem I've got is I don't know what the variables are that are causing the problem. Is it that this material is old, is bad, and, you know, is just junk? I should just toss it in the trash and buy fresh, and a fresh batch of material would actually perform better than what I'm getting currently. That is absolutely possible given the experience that we've had to date with this batch. That is a viable reason. It's so yeah, I'm not overly impressed with the quality of what I'm using right now because it's just so dang problematic. So yeah, show of hands in chat. Should I go with the UV resin, or should I go? Should I stay or should I go now? Should we do a side by side etch? Yeah, it could be. Right, okay. So, that's the one I want. So this is what the board looks like now. I've got like a patchwork quilt of little repairs that I've done. So I'm going to try an experiment. So I'm going to get a fresh FR4 board. And I'm going to clean it the same way I cleaned the other boards. You love experiments, what we're doing. Experiments. Oh, yeah. You're not wrong there, buddy. You're not wrong. Okay, so I've got to think about how I can protect my screen because I don't want to get resin on my screen. That would suck. So I've got a couple of options here. I can put down this material here, but it could leak out the sides. Or I could put it in the vat. I could put the vat in. I could put the vat in and see whether or not the vat would actually, we get a good registration. I mean, all I need oh man, we're gonna be yeah, experiments on experiments on experiments. The extension on the extension on the extension. Please tell me, somebody, please tell me. That's probably the safest for the screen. Yeah, I would tend to agree with you, I would tend to agree with you. I think the vat is probably going to be the better option. Right, we're going to clean this with some IPA. Now, the resin I've got is water washable. I've got a vat downstairs that I can use to clean that up. So let's try something here, right? Let's put
let's put the VAT on, and then let's see whether or not that's going to work. Let's go to studio mode. Otherwise, put down protection film. Yeah, the only thing is the more layers that we've got, covering that, it's going to be problematic, right? Oh yeah, I forgot to turn that doodad off, didn't I? Studio mode. Doop. It's being a bit of a derp. Okay. Right, let's try it. What I'm going to do is I'm going to put the VAT. I'm going to put the VAT on. I've only literally just changed the FEP sheet on it. So what I really don't want to do is poke a hole in the FEP sheet with a circuit board, right? That would be not good. Okay, and what I'm going to do now is I'm going to run the PCB test. I want to see where this registers. So we're going to see where the light comes on. Right, okay. I'm going to need a sacrificial spacer. The spacer we've used to date is something that we need. So what can I use as a sacrificial spacer? Oh my word. Because if I put that in there right now, that's not going to work. No, we do need that offset. So what can I use as a sacrificial spacer? Is this material enough to bump up against? I suppose it is. We could probably use this material, this plastic sheet. If I cut that square enough, which we know I can't, but okay. So I've now got a little piece of plastic which I'm going to attempt to use as a spacer. Okay. Think this through, Steve. Think this through. Okay, we're going to stop. Going to place this piece of plastic inside the vat against this edge here. In fact, we're going to flip it around so we get the square edge against the board. This is going to be interesting to see whether or not this works. All right, so I've got some, what is this? Is it Algu? Yeah, Algu, ceramic gray. I'm going to just put, in fact, no, let's check the registration works at the moment. I just need to make sure the registration works. So we're going to be about there. Yes, that will work. Okay, so what do we reckon? Put the resin on the board, put the board in the vat, or put the resin in the vat and put the board on top of the resin? I think we shouldn't mess with what already works. I think we should put the resin in the vat. I'm gonna YOLO it. Here we go. We don't want a large amount of resin. Okay. So I've just poured a tiny little puddle. So I'm going to get some tape. And I'm going to create like a little tape loop on the back of my circuit board. So I can use like a handle to be able to pull the board out. Okay. So now I'm going to drop this in and I'm going to register it. Oh man, is this going to work? I have no idea. This is like crazy. Okay. So the board is in the resin. The resin is squeezed out across all the surfaces. So now I'm going to do 3 burnt in layers. I'm going to get the lychee slicer up. I'm going to do 3 burnt in layers. And I'm going to use my standard resin settings. Right, so we're going to change this to, oh yeah, this is the Algu, right? I think, yeah, Algu. 30 seconds, 3 layers. Export. This is going to be mad. Gary T! No, we're good. We're good. We're so we have done an export. We set it up, but the problem I'm getting is an inconsistent. What do we call this? Resin. I'm getting inconsistent application of the UV resin coating, and I've had to do a lot of patchwork on this. So, right, it thinks it's going to take 21 minutes, but it's not going to take 21 minutes because we're not going to allow it to expose for that long. So, right, let's just get this done. So, what we're doing now is we're trying to apply resin directly to an FR4 board to see whether or not we can get a to see whether or not we can get a circuit board etch with just the resin, right? Here we go. Use UV resin as a mask. I'm going to need the glove up to get this cleaned up. Here we go. It's going to be mad if this works. Okay, that's layer 1. We'll let it do 3 layers. And then we will we'll give it a wash. That's layer 2. So it's just got to be enough to resist the acid. So the question is which one do we etch first? Do we etch the UV coating one, or do we etch the resin one? So have a think about that. I'm just going to go and clean this up. I'm going to glove up, and I'm going to get this just processed and see whether or not we've actually got something usable here. So so the question I'm asking chat is, which one do we etch first? Do we etch the one where we apply the manual UV coating, or do we etch the one that we put resin on? Now, I'm wondering whether or not there's going to be some sort of weird reaction with the resin. So my vote would probably be to etch the UV one, so that if we taint the ferric chloride through our weird-ass experiment, we can kind of recover a little bit. Okay, so this is definitely stuck to the to the FEP sheet. Ooh, there was a definite pull on that. Ooh. Ooh. Oh, no. Oh, no. Okay. Okay. I can see it's overrun. Okay. Okay. That's interesting. Okay, it's overexposed. That's the first thing. Okay, I'll clean this up on camera because you want to see this. You want to see this. I almost took this off, but I think this is going to work. As long as we don't get a weird reaction with the acid, I think this process is going to work. Right, okay. So I reckon maybe one layer is enough. One exposure layer is enough. So have a look at this. So first and foremost, we didn't get the registration quite right. So I need to fix that. But I think that's going to work. So, right, let's think about this carefully. Okay, I think we can go for another attempt. Yeah, right? I reckon one pass. I think one pass will do it. But we got to get our registration correct. So we got the registration on the left, right, correct? But we need to get the registration top to bottom. So I need about a centimeter. I need about a centimeter gap off the bottom. Okay, so I'm just going to put some more resin in here. Okay, have I got it on the right camera? Yes, I have. Okay. Okay, so we're going to do one pass of this. Oh, is it going to work? Is it going to work? Is it going to work? Oh my gosh. I have no idea. Okay, so that's a single pass. Okay, it's stuck to the FEP sheet like before. Okay, I'm going to have to take this out. Okay, okay, okay. Oh. Eek. 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 I've got myself in a mess. Water, water, water everywhere. Not a drop to drink. Put you in there. Because that's water. I need fuel to clean up the drips on my resin bath. You don't want to spill resin. Okay, maybe one pass is not enough. I'm looking at that and I'm seeing little traces of stuff. Maybe I need to rough up the surface a bit more than it is, but let's go clean this up and see what we got. So we went overexposed the first time. We could be underexposed this time. So maybe we do something in the middle if that's the case. But we will just quickly clear this up. Okay, so, man. Yeah, that's not going to work. That is not going to work. Or is it? Oh, okay. I'm willing to give this one more shot. I've just had a bit of a brain wave. So let me show you what I can see, and then I will give you my synopsis of where I think we should go with it. And it'll be one more exposure attempt. And if that doesn't work, we're just going to stick with the UV coating for now, and see whether or not we can get a result of that. So, oh, I'm losing bits. Let's put that in there. And now we'll show you what I've got. This is dang close. This is dang close. I think if the next option that I've got is potentially going to be the option for us, right? So, so here's what I've got. It's pretty close, but it's not sticking across the whole plate. So my thought is to use the, oh man, that peels so good. Use the sandpaper. If we use sandpaper to rough up this surface, the resin is going to have a better time holding onto it. But the question then becomes, how do we remove that resin if it bonds to this thing like and doesn't want to come off? That's the other side of the coin. If we get it to bond too well to this material, then we've got an issue getting it off. Where's my scraper? I need my 3D print removal tool because this doesn't want to come off. But we're close. We are incredibly close. I reckon this copper surface is just too shiny. That it doesn't, it's not sticking to the copper. What say ye? Do you agree? Do you think that's a worthy sort of test? Well, race, you never know, mate. Right, here we go. I'm going to use the 120 grit sandpaper. Let's move you out of the way. I'm going to use the 120 grit sandpaper to scuff this surface up. Make it nice and rough. Okay, and now let's use some IPA to clean that surface up. Hey, yay! Okay, so if you have a look at that now, there's lots of like little micro scratches on the surface. Now the idea is that those like micro scratches hopefully will give a bit of a key for the resin to bond to and hopefully stick on there. All right, one more attempt. And if this doesn't work, this is like the most ideal conditions for this to work. So if it doesn't work, then it's not gonna work. Okay. And go. Okay. Let's remove this from the vat. Nope. We got traces off already. So it's not looking good. Not looking good. Oh man. The only thing I can think of is that the head of the resin printer does press down quite firmly. So is this a dispersion issue? But no, it's not sticking. We're overexposed in some areas, and it's not going to work. Dang it. Okay, how can I fix this? How can I make this work? It's so flipping close. I reckon scuff the surface up, put something heavy on it. All right, okay. Let's see what we got, guys. Let's see what we got. This is what we've got now. So we're still like not bonding this to the board. And it could be because of the amount of pressure or lack of pressure being applied. But yeah, this is quite a satisfying peel, right? I grab the ground plane, see if I can get the ground plane to come up in one. No. Put a finger on the board while it's running. Yeah, push try, but it kind of does move around a little bit. Do you know when you you've got two surfaces that have got water in between them and they kind of slide against each other? That's kind of what's happening. So here's my thoughts. Oh, that's stuck pretty well. Oh wow. Right. Okay. Maybe I need to rough the surface up a bit more. Because I'm having a bit of a challenge. I'm having a bit of a challenge getting the resin off. Oh, there we go. There we go. Now we got it. Okay. Bit of scrap paper here now. Just to get all of the excess resin off. I think we need to sand this again. Also, when you take it out, don't rub it up. Rinse it off with alcohol and cure it again. Yeah, that is the intention. That is the intention. So I've got a water bath downstairs. This is water washable resin. So the idea that I'm trying to get to here is we get so it's coming off as I'm removing it from the FEP sheet. In both cases so far, when I remove it from the FEP sheet, there's like little trails of the circuit that have come away as I'm removing it. So if it's coming off at that point, you know, it's too fragile. Way too fragile. But I am intending on curing it under a UV light to make it like completely rigid. So I guess I'm just pondering what to do in terms of getting this to grab to the plate. My sort of thought is that when this is in the machine, I'm thinking a moment. I've got an idea. This could be pretty dumb, but I have an idea. So I'm going to take the resin vat away. And what I'm going to do, I'm going to take my gloves off a minute. I will need to put them back on, but I'm going to take them off for a second. I'm going to get a sheet of copy paper. And I'm going to zero the printer. But I'm not going to zero the printer under normal conditions. I'm going to zero the printer with, let me see, if I got a really thin piece of film, what have I got? What have I got that will do the job? It's too thick. That's too thick. Right. You're supposed to do it with a piece of paper, right? The thickness of a piece of paper. So what I'm thinking is if I put the circuit board in the right spot, right, on the FEP sheet, and have the head come down and press on it, I just need to make sure that I don't do it in such a way that I damage my screen, because that would suck. That would suck big time. Oh, that'll do. If I put that on there like that, right, and then we get my circuit board, put my circuit board on top, like that, and now get the print head, put that on there, like that. In fact, let's take it off, because I don't want to damage anything, because, well, for obvious reasons. Let's go to Tools, move Z, and then we're going to Home. Okay. Now, okay. So I just set the Z height. This could be really silly. But I think it's worth a shot. Okay, so I'm going to do is I'm going to glove up. That's what you're going to do, Steve. You're going to glove up. And you're going to expose the resin for approximately 15 seconds. And then I'm going to cancel the job. And then we're going to take it out and see what it's done. This is this is an experiment I never expected to experiment with, right? So, okay, so let's put the plate in. Okay, here goes nothing. I just hope I don't hear a crunch. Okay. Ooh. Okay, we've got. Oh. 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 Hello. 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 That looks pretty promising. Okay. Okay. Let's see what we got. Let's just get this off the print head and see. That might have actually just worked. Okay. Oh, you're kidding me. That's. I wish you guys could see this reveal, right? But okay. Right. Right. Okay, I think that needs an alcohol wash and then maybe a cure. But we could be in business here. We could be in business. I only say could. You just dry this off and I'll show you what I've got. The problem I've got is I can see there are traces that are not the trace separation, you know, the gaps, the isolation parts, they're not isolated. So, oh man, this is so close. This is so close. So let's put some IPA on here and see. Oh, it's coming up. Because of course it would come up, right? Okay. I got a theory. I think this is overexposed. I think this is overexposed for what we need. And I think if I can expose this, I mean, we did, what was it, 15 seconds. So I reckon if we do 7 seconds, that will probably be enough. And then, right, okay. This is the last attempt. And I've said that before. I keep coming back to this. So this is going to be the last attempt. I think we're overexposing it. And I reckon if I expose it less to get the separation, and then do, think, Steve, what do you want to do? Yeah, get the separation and then expose it under a UV cure light. That could possibly be the sweet spot. I mean, you think circular scratches, so I'm going to really stuff this up. I'm going to give this the best possible scenario for success. This is mad. This is mad how close we are. Tense stuff. So I think I'm going to give it a bit of an IPA wipe. And do we think an acetone wipe would be full at this point? No. I don't want to mix chemicals. IPA is one thing, but mixing acetone with UV cure resin, I don't know how that will react. Right, so I've now got a really sort of scuffed up surface. Which is still dirty. I'll make it as clean as I can. Okay, give that a moment for the IPA just to evaporate off. And then we're going to go again. Oh, man. It's tantalizingly close. Tantalizingly close. This is really frustrating. How close this is. So we did 15 seconds, and I think it's overexposed it. So I think maybe half that, and see how we get on. If we do half that time, okay, just quickly coat the FEP sheet. So you only want a really thin coating of resin. Okay, let's put the board in. Now, on the downside to this approach, we're not going to be able to do a solder mask. But at this point, I don't care, because all I want is a successful drop on the UV. All right, 7 seconds. That's what we're going for, 7 seconds. Get the cancel menu up ready. One, 2, 3, 4, 5, 6, 7. Okay, we had a good thunk. Okay. We've got something on there, but I don't know how good this is going to be. I think this might actually be a worse attempt. So we'll see. We'll wash it off and we'll see. Oh, man. Right, it's peeling up. Yeah, that's a fail. So, I know I said I wasn't going to do another go, and it was going to be the last one. But I'm wondering whether 10 seconds. I'm wondering if 10 seconds is going to be where it's at. I'll let you guys see and you can tell me what you think, but I think 10 seconds is... We've got good separation on the traces. It's just not strong enough to bond. It's not strong enough to bond, so... Yeah, that's real close. That's real close, damn me. Man, this thing is teasing me. It's like, oh, nearly no. Oh, nearly no. Steady, steady. Okay, that's what we've got. So, any recommendations on how we can get this to stick to the board a little bit more consistently? I have a sneaking suspicion it's just going to be exposure time, to be honest with you. Because I think if we can get this, if we can get this to get through the first exposure round, right? If we can get that and get a good definition on the circuit, I think that there's a reasonable chance of us getting it to, at least getting it to the etch stage. Because right now it's just being a complete and utter pig. Is too few. What's the middle ground between 7 and 15? What's the midpoint? Okay, I should be back. All right, so unfortunately, we got another failure. Let me show you the failure. No, wrong camera. Let me show you the failure. So that is so dang close. That is so dang close. And these traces got pulled. All these pads got pulled when the head lifted. The suction was sufficient enough to pull these traces off the board. So I think 11 seconds is probably the low end of where we want to be. The question is, do you want to endure another attempt, or do we go into etching the other board? I'll let you guys decide that, because I just don't want to keep going around in circles with this. But it is pretty close. It's just got to survive that pull. If it can survive the pull, then the likelihood is we're gonna get it. But it's that surviving the pull that's the problem. So I'll let you guys decide whether or not you want me to go for another attempt, or whether you want me to go into entering the other board, because what time is marching on. So what do you guys think? Do you wanna go for another attempt, or do you wanna go for another attempt, or do you want to etch the other board? I will leave it up to you guys. It's only midnight, still early. You would go for another one. Okay. So that was 11 seconds. That was 11 seconds, and it was just too soft to survive the pull. Now, 15 seconds overexposed, and we lost the separation. So we want to find a middle ground between 11 and 15. And to me, that sounds like 13 seconds. What's you guys' opinion? Okay, this is the final call, right? This is final call. If this does not work, I'm not saying I'm not going to experiment with this idea, but we're not going to do it tonight, right? One more attempt. So the microphone is has pretty much died on battery. So yeah, that's something I'm working through. I've got it on charge. Okay, put another set of gloves on. You know what? Let's get a fresh set. I think I'm down to almost my last pair. In fact, yes, this is the last pair of gloves. So I'm going to need to order some more. So you think 13 could be the winner? No, okay, well, let's see how that goes. And then it's going to be a case of very gentle wash up to get that to stay. But yeah, it really doesn't want to stick to this board, to be fair. Okay. Tell you what, screw it. Whatever's in the vat is probably going to be going in the bin anyway, right? I'm not gonna put excess resin from the vat back in the pot, seeing as I put foreign objects in it and stuff like that. So I am going to go with an acetone wash or wipe of the board. So let's see if I put acetone on this. I know I'm adding a new variable into the mix, but I'm wondering whether or not there's something on the board that is preventing it from sticking. And it does seem to be like a yellow residue coming off. Time to get the marigolds, right? Okay. So let me just give that another wipe over with a dry cloth just to make sure there's no acetone still on here. It should evaporate off because it's quite the volatile liquid. So here we go. Whatever happens now, the next step is etching. We will be etching a circuit board momentarily. We're going to go 13 seconds to see if we can't use a UV printer, a resin printer, to apply a solder, an etch mask to a circuit board. That's what we're trying to do here. We're trying to apply resin so that we can have an etch mask. So let's put this puppy down in the liquid. Let's get it justified and ancient. It would help if I had the print head. Give me 1 moment. Okay. 13 seconds. 13 seconds. No, it's 99% acetone. It's proper acetone. It's not nail polish remover. Nail polish remover is mostly water, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Come on. Okay, so we've lost a little bit of the ground plane, but that may not be the end of the world. So I'm going to be incredibly careful washing this off now. Give me 1 second. Okay, we got a result, and it's not the one we want. Unfortunately, it's a failure, and it's a failure significant to tell me that there's more going on here than we would like. So let's have a look at it momentarily. So it's overexposed. The separation of the isolation lanes is no good, and we've also lost definition in the small pads. So unfortunately, I'm calling it there. That's futile to go any further with that experiment. So now we're going to go back to the original plan, which was to etch that board that we've prepared already. So let's get to that, and we'll see how that turns out. We've got everything we need to get that underway. So let's bring in the ferric chloride. Ferric chloride is the active agent for removing the copper. I've got to be incredibly careful not to spill this on my bench. So there's the ferric chloride, the goo, the schmoo, the horrible stuffs. And what we're going to do is we're going to take our circuit board that we've prepared with all of the patchwork that we've done, and hopefully we can actually get a decent etch off this. So I'm going to drop this in, and then I'm going to get the other camera in here so you guys can see the etching process. That's in, and let's get the camera. Let's move the microscope out of the way. At the moment, it's sat on top of the acid. Let's switch scenes. All right. So now let's just zoom, and then we're going to get a Q-tip. I'm just going to poke that just so it submerges down in. And now we've started the process of removing the copper. And we'll have to wait and see how well the pen. I mean, it's not a dedicated etch resistant pen, right? So let's be real about this. It could very well fail badly, but you know, that's why we do these things. We experiment to find out. It's really frustrating though that that UV resin, sorry, the UV coating that we have applied was inconsistent. So I don't know. I might just look into that and see if I can off camera do an experiment on getting that application process down. It's a little bit of a disappointment, really, that with all the steps that we took to get that applied, it still behaved the way it did. So, and actually, I don't think it's the age of the material. I think it's a combination of surface preparation, and I think it is also the process of laminating it. So I gotta have a think about how we can possibly improve that process. Right, so right now the ferric chloride is currently dissolving the copper that is exposed and should hopefully be leaving behind the traces. That was for etching. I mean, it was pretty close. It was pretty close. I mean, that's where we got to. But close, but no cigar, right? It's disappointing to get that close and not get there, but I don't know if it's the type of resin that I'm using. I mean, it is water washable resin. Whether that has a bearing on things, I don't know. But we were attempting to get a etch mask applied. Right, let's use this Q-tip just to lift the board up and just see how we're getting on. So the copper is turning like a pale color. So that is good. Now we're not really going to know how good or bad this etch process has been until we put this in the water bath. And well, one, get it in the water bath, and two, get it in the sodium hydroxide to remove the etch mask. So all I'm doing here is just agitating the liquid so that there's like a flow or current of movement across the surface of the board. And that just means that it washes any freshly dissolved copper is removed for a fresh bit of ferric chloride to come in and eat away at what's left. And we're just going to keep repeating this process, checking it, make sure we don't leave it in the bath too long, all of that good stuff. Sometimes it can be a little bit difficult to see whether or not the copper is completely gone or whether or not, you know, it's got some left to etch. So we're going to make the best of it. And I just hope that the patchwork that I've done is going to be sufficient enough to make this board usable. If this isn't good enough, then I'm probably going to put some bodge wires in and just make it work. So that's, like I say, that's a little bit disappointing, but you know, we know that the resin printer part works for the exposing, the exposure. So 3 minutes exposure is good to get a decent mask. It's the application of the UV sensitizer. That's the kicker. If I can get the application process nailed, I think we have a more than 70% chance of success. Okay, we've still got copper to go. Get in there. So one thing I do want to make sure we do is to get a decent etch around the small pitch pins. We've got 1mm pitch pins on the FPC connector. They are staggered, so there is a 2mm gap between the pads in the same plane, but last time I etched, we had a bit of an issue with. Oh, hang on. Are we close? It might be close. Yeah, we're getting there. I'm starting to see FR4 board now, so we are not far away from, a few minutes away from this being etched. But as I say, we need to make sure we got good clearance on the small pins. So if anyone in chat's got any questions, feel free to engage. Feel free to chat away. I'm all for demonstrating things, but having good conversations is always a must, right? So if anyone's curious about what I'm doing, if anyone's curious about the technique that I'm using, feel free to ask. And if there's anything off topic you want to talk about, that's absolutely fine also. Right, I can definitely see the copper disappearing now. It's so I don't know if you can make that out. Don't think you can, but I can definitely see copper retreating. So that's a good thing. So, stages that we're going to be going through between now and the end is we're going to finish the etch. Then this circuit board's going to go into a water bath just to reduce the acidity by dilution of the ferric chloride. And then it's going to go into an alkaline bath. Maybe I should do it with gold. But dissolve the gold. That would probably require me to have some aqua on hand. I don't carry aqua with me, unfortunately, and it's probably not something that I want to have kicking around. I have considered urban mining and like retrieving precious metals from electronics, but the chemicals that you need to handle to be successful with that at scale, it's not nice stuff. It is not nice stuff at all. Okay, so I'm going to tip the board up, and you'll see that the copper's gone around the perimeter. The copper also appears to have gone in between the traces. So I'm going to leave this in here for maybe 2 minutes more to make sure the copper has gone. I don't want to rush removing it from the acid bath. There is a risk that I over-etch this, right? And I cause damage to the traces that I want to keep. But I want to make sure that the small pitch components are completely etched appropriately. Now, when I do the water bath thing, it's going to be a little bit difficult to capture this on camera. So yeah, it's going to be a bit of a challenge. All right, let's take a look at that. I'm going to hold this up to one of my studio lights. I'm just going to let this drip off. I'm just going to use my Q-tip just to help get rid of the ferric chloride. I'm going to hold this up to my studio light. I want to see whether or not the traces are etched sufficiently, and they look like they might be. I can't say for certain. Okay, it is what it is, right? It is what it is. So here we go. I'm gonna switch over, and I'm gonna just do a water wash. Like I say, I can't really show this, unfortunately. So this is going straight into water. Just gonna rinse that off. All right, I'm gonna hold this up to. Let's dry this off with some scraps. I'm going to hold it up to a bright light, and I'm going to see whether or not we've got. Okay, that looks pretty damn good, actually. That actually looks really good. I'm actually surprised. Right, let's get this ferric chloride out of here. It's nasty stuff. I just don't like it hanging around. Okay, so have a look. Now, the way that I tested it, let me show you what I just looked at. Let me just wipe my hands because I can see there might be some ferric chloride on my gloves. So I don't want to handle tech with ferric chloride eating them, will we? Hard enough getting tech as it is. Anywho, right, so if I hold that up to the light, right, and then I put my circuit board in front, there's really good separation on those traces right there. So the copper, there's the copper side, and we're looking from the end of the board, right? So if I now look at the other side where the really fine traces are, that equally looks pretty good. So I think what we're going to do is go over to the line bath. We're going to drop that in there, and we're going to remove. We're going to remove the etch mask. No going back now. No going back now. Put you down so you can watch that break up. Okay, so yeah, that's such a pity that that didn't work with the other board. I think it was close to working, but close but no cigar. So what we're waiting for is that etch mask just to start crackling and breaking up. The etch mask is acid resistant, but it is not alkaline resistant. So as we apply a heavy base to it, it will start to crinkle up and disintegrate. Yeah, that is such a shame. Anyway, right, okay, so how's that looking? Is it coming up yet? No, not yet. Let's get my scraper. I'm just removing this attempt at a solder, or sorry, at an etch mask. I think it's close, and if you can get the material to bond sufficiently enough to the copper, I think you could probably do it. I think the challenge is the suction. The liquid is quite viscous, and the suction is so great that it's just sucking the tracks off. God, that's not a sentence I thought I would say. Yo, Dimitri, how we doing, buddy? How we doing? We've got an etch. We've got a successful etch by the look of it. Fingers crossed, we're going to be able to remove this etch mask. We did have a crack trying to 3D print directly onto the circuit board, and that didn't go so well. But yeah, we're looking at. I think I might put some more sodium hydroxide in that. Where did I put the pot? Here we go. That would probably be a bad idea, but you know me and bad ideas. Okay, I think that's coming up. He says, think again, Steve, think again. I don't know how much of the marker pen is actually holding some of this stuff on. It's almost like clear gelatin at this point. All right, okay. I think what I'm going to do is take it out of this bath, get rid of this slurry, and do a water wash, and then I'm going to use, I think I'm going to use the. Is that gone? What on earth? Okay, I'm going to wash this under a flowing tap. Give me a second. Let us use the wire wool technique now, and hopefully the wire wool will remove the remaining crud that is on this board. Let's go, 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 gadget, go. Okay, I think I might put a bit of acetone on here. I think that might help us along a little bit. Yes. Yeah, we tried to print directly onto the board to try and create a resin-based solder etch mask, and it didn't work. We were close. We were very close, but it didn't work. So that sucked. Okay. We're getting there. We're almost done. Okay. Have a look at this. That, in fact, we can get a better view than that. We can definitely get. Yeah, we tried. The problem we had was that the suction between the FET peak and the copper was sufficient enough to pull the tracks off, the ones that we laid down. So good way to test it, hold it copper side towards us, copper side away from us, and you can see how good that is. So now the proof is in the eating, right? When we get our multimeter and just test the tracks continuity and see whether or not we've got a usable circuit. So let's get. What do you mean on the circuit that I built here? Or do you mean on trying to 3D print? Right, I'm going to test continuity from the ground to each of these pads. No ground, 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 no ground. Awesome. So these are all like TLL logic levels, and the ground is isolated. Perfect. Okay, so now we got to see whether or not we've got continuity from track ends. Continuity. 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 Yeah, I don't know if you're hearing the beeps. We're all testing good so far. All good, all good, all good. Yes, come on. Right, I don't know whether or not you heard any of those beeps. The meter is directly next to the. Get in. Come on. Oh, thanks, Dimitri. Back in the 90s, we laser printed on the transparent plastic and used copper with a premium. Yes, yes. So I wanted to use the UV resin printers attributes to etch the board, or at least expose the words are escaping me right now. The etch mask. So we were able to expose this to get the etch mask done. In fact, let me see if I might be able to show you better the quality on here. So that has beep test completely, perfectly, super fantastic, fandabidozy. Loves it. I does. So I guess I got to consider whether or not I want to put a solder mask on here. I do have the solder mask layered up, ready to rock and roll. The question is, do I want to apply it? And at this moment in time, I don't know. Pre-mounted photosensitive layer, managed to get 2 tracks between contact holes. That's pretty sweet. Guido, that's pretty cool. So that is totally usable. Let's get that in the center. Maybe that can be the thumbnail for this live, right? Alrighty. Okay, peeps. I gotta now contemplate calibrating for etch mask and seeing whether or not we can get an etch mask on here. Not an etch mask, a solder mask. And if we can, then that would be the next logical step to take. It's also going to help me identify my drill holes. Use an expensive 200-watt UV light bulb back then. Yeah, right. So that sounds like the sort of setup you would use for you would have used for screen printing, like for screen printing T-shirts and the like. So, but I am super happy that we've got a positive result out of this. We have a usable board in terms of the electronics, and yeah, will I use this process again? Yes, is the answer in short. I think I would like to develop. Yeah, all right. I would like to develop the skill of being able to use this and possibly get down to being able to get like 0.5 millimeter pitch components, whether it's ICs, flat cable connectors, and the like. But this I definitely think it has potential. It's just the big thing is the application, the UV layer application. That's the kicker. So I wonder whether it's worth me see if I could pick up a stock of pre-sensitized circuit boards. I think I may even have one that's pre-sensitized, but I'm not entirely sure how it's developed, if it's developed in the same way as this board, or whether or not it uses some different chemical to develop it. But the pen did the Sharpie going over the tracks that were bad. The Sharpie did a decent job of correcting that issue, and yeah, that is the net effect we've got a usable circuit board. And a solder mask is going to help protect this circuit board from corrosion. If you don't put solder mask on, you get corroded boards, and I know all about corroded boards with nothing on them, right? So we don't want to go down that road. Well then, guys, it's been a blast. We've got there. We've got a result. That's where I wanted to be tonight. So I will look to close the stream here. Thank you for everybody hanging out. I appreciate every single one of you. If you're watching in the VOD, if you've got this far, oh my gosh. Thank you so much for hanging out. Please put your comments down below of how you would have approached this, this particular challenge and whether you would do something completely different. Until next time, have fun, be safe, and I will see you in the next one. Bye for now.